You know, every single day, we experience just a little bit of magic. We flip a switch, and the room instantly lights up. We plug in a coffee maker, and it just starts brewing. But behind all that effortless convenience is a heavy-duty infrastructure, and it's all anchored by that somewhat scary gray metal box hiding in your basement, garage, or hallway. Yeah, you know the one. That box you kind of try to avoid eye contact with when you go down to do the laundry. Well, welcome to today's Explainer, where we're going to completely demystify the electrical panel. By the end of this, you won't just understand how it distributes power, you'll understand exactly how it's working around the clock to literally keep your house from burning down. All right, here's a quick roadmap for our explainer today. First, the heart of your home. Second, anatomy of an electrical panel. Third, fuses versus circuit breakers. Fourth, warning signs and troubleshooting. Fifth, upgrading costs and capacity. And we'll wrap up with the golden rules of panel safety. Let's get started. Section 1. The heart of your home, the master traffic cop. Okay, let's dive into this and establish what this gray box is fundamentally doing for your building. The electrical panel is the central distribution point of your entire home. But honestly, it's better to think of it as a precise boundary line. Everything upstream of this panel belongs to the utility company, and here's the absolute crucial detail. It remains energized and live at all times. Everything downstream of this panel, that's your building's internal system. Every single light switch, outlet, and appliance traces its power directly back to this box. But it's not just about passing out electricity. It's the primary safety device for your entire home. It constantly monitors the current, and if a wire gets overloaded, it completely cuts the power before that wire can overheat and ignite. Moving right along to Section 2, anatomy of an electrical panel inside the box. To really demystify the panel, let's see how this builds. Imagine just stripping away the cover so we can trace the exact journey the electricity takes to get to your appliances. First, it arrives from the utility company, passes right through your electric meter, and enters the top of the panel enclosure. Once inside, boom, it hits the main breaker. Think of this as the master on and off switch for the entire building. From there, the power flows down onto these flat metal conductors called busbars, which run right down the center of the panel. Finally, the individual circuit breakers clip directly onto those busbars, drawing the power and sending it out to very specific circuits all over your home. And this brilliantly illustrates the exact anatomy of how all those components fit together in one space. You've got the main breaker at the top, setting the total ampacity limit. The bus bars run down the center, and those individual circuit breakers clip right onto them. You'll also notice the neutral bar and ground bar on the side rails. Those basically complete the system by returning current to the utility and providing a safe path straight to the earth if there's ever a fault. But listen, I really want to draw your attention to the absolute danger zone here, the service entrance conductors. These are the massive wires bringing power from the meter to the main breaker. They are always live, always. Even if you flip that main breaker to the off position, those incoming wires will severely shock you. They must never, ever be handled by anyone other than a licensed professional. Section 3. Fuses versus circuit breakers. The great debate. Now, what's really interesting about this is the stark contrast in technology. If you live in a home built before the 1960s, you might actually be dealing with some pretty outdated stuff. A fuse box relies on a single-use fuse. It literally contains a tiny metal strap that is designed to melt and permanently break the circuit if it gets overloaded. Once it blows, that's it. You have to physically throw it away and screw in a brand new one. A circuit breaker, on the other hand, is a modern mechanical switch. If there's an overload, it just trips to the off position. Once you fix whatever caused the issue, you literally just flip it back on in seconds. But the real issue with fuses, it's a highly dangerous practice called overfusing. When a fuse keeps blowing, homeowners get frustrated, right? So they're often tempted to just screw in a higher rated fuse so it stops interrupting their power. No way. That completely bypasses the safety mechanism and turns your home's wiring into a direct fire hazard. That is exactly why fuse boxes are completely obsolete, not permitted in any new builds, and can even cause your insurance premiums to skyrocket. Which brings us to Section 4, warning signs and troubleshooting, cries for help. Your electrical system will usually tell you when it's operating under dangerous stress. We just need to know how to listen. So why is my electrical panel hot to the touch? If you ever place your hand on your panel and have to ask yourself that question, you need to act fast. A noticeably hot panel is absolutely not normal. It's a massive red flag indicating that the system is operating under severe stress. It could mean there is a sustained high current draw, a loose internal connection that's generating heat through electrical resistance, or maybe even failing breakers. Make no mistake, panel heat is one of the clearest, earliest indicators of an impending failure. Let's run through the full list of these warning signs. If your breakers are tripping frequently under a totally normal load, or if they absolutely refuse to stay in the on position after you reset them, you've got a persistent fault. If you see flickering lights that definitely aren't caused by a neighborhood power issue, your main breaker or service connection might actually be failing. But I want to heavily stress these next 2 points. If you ever notice a burning smell or see scorch marks near the panel, that is a potential fire emergency. You are witnessing active arcing or melting. Second, if you open your panel door and see the brand names Federal Pacific Electric, which is often labeled Stablock, or Zinsco, you need an upgrade immediately. These specific brands have deeply documented histories of breaker failure and fire hazards. If you see literally any of these signs, please do not play detective, call a licensed electrician. Section 5. Upgrading costs and capacity, sizing for the modern era. So the crucial point to keep in mind here is this number, 200 amps. Look, we're asking our homes to do more than ever before, right? We've got EV chargers, heat pumps, induction ranges. Historically, 100 amps was totally fine for small homes running gas appliances. But today, 200 amps is the new universal baseline standard for residential construction across the United States. It comfortably handles modern electric appliances, central HVAC, and a typical EV charger, all with some headroom to spare. Now, if you have a massive home, multiple electric vehicles, or whole home battery backups, you might even be looking at a heavy-duty 400-amp panel. Of course, upgrading your capacity does come with a price tag. Let's walk through the realistic costs. If you're doing a simple like-for-like replacement, say just swapping out an old 200-amp panel for a brand new one, you're looking at between $1,000 and $2,500. Bumping an old 100-amp service up to that modern 200-amp standard, that usually runs from $1,300 to $3,000. Moving all the way up to a 400-amp service is a major project that often starts at $2,500 and can easily exceed $5,000, mostly because it requires heavy utility coordination and brand new incoming conductors. Now, if you just need more circuit slots but you already have enough total power, adding a subpanel is by far your cheapest route, usually between $500 and $1,500. Also, just a heads up, replacing an obsolete fuse box can cost up to $4,000 just to get everything up to modern code compliance. And remember, a licensed electrician absolutely must perform a formal NEC load calculation to determine exactly what size you need. Oh, and always make sure your quotes include the permit and inspection fees. All right, our final section, Section 6, Golden Rules of Panel Safety, Hard and Fast Boundaries. Look, the electrical panel is easily one of the most hazardous components in your entire building if it's handled incorrectly. So we need to establish some absolute ground rules for interacting with this equipment. Number 1, do not DIY panel work. The high voltage conductors inside that enclosure can cause a fatal electric shock. Always hire a licensed, insured electrician. Number 2, if you ever absolutely must touch something inside, never ever do so without shutting off the main breaker first. And remember what we talked about earlier? Those top service conductors are still live even when it's off. Number 3, never block your panel. The National Electrical Code strictly requires a minimum 36-inch clearance zone in front of it. You can't put bookshelves, storage boxes, or furniture in front of it. In an emergency, you need instant access. And finally, never defeat a tripping breaker by replacing it with a higher rated one. If a 15-amp breaker keeps tripping, jamming a 20-amp breaker in there doesn't fix the problem. It literally just allows the wiring in your walls to overheat and potentially catch fire. So that brings us to our final big question for this explainer. Is your electrical panel actually ready to safely power your future? We've explored the anatomy, the warning signs, the serious dangers of old fuse boxes, and the capacity requirements of modern life. Take a moment today to go find your gray metal box. See if it's warm, look at the brand name, check the amp rating on the main breaker. Understanding exactly what is happening inside that panel is absolutely the best way to protect your home and ensure you're ready for the next decade of electrical growth. Thanks for learning with us today.